Okay, good morning. Welcome to
Number 870.
870. So this is going to be kind of an advanced topic for you because this has a little bit more trigonometry, some sines and cosines in it, and this is actually the next topic you're studying in calculus. And it's kind of a fun continuation of the planetary motion we talked about yesterday.
Okay.
So in algebra, you're studying lines, right? And for a line, we look at a general point in the Cartesian plane.
Yep.
And we call it x and y.
Mm-hmm.
And can you give me an example of equation of just a random line? What would an equation of a line be like for you?
It means like 2x plus 3y is 6.
That's right. And that tells us the relationship between certain points in the plane.
Yep.
And identified as their x coordinate and their y coordinate.
Yep.
But there's a different way we can identify points in a plane, and it's called polar coordinates. And do you know? Have you ever heard of polar coordinates before? What do you know? What are polar coordinates used to describe the location of a point?
So you use the distance away from the origin.
Okay. And typically, what is that called?
That's called r generally.
R. Why do you think they use r for that?
For radius.
Yeah.
And then you use this angle on the x-axis.
Theta. So this xy point corresponds also to r and theta.
Alright.
And do you think it's a coincidence we needed two coordinates both times to describe that?
Probably not.
Yeah.
Why would you guess we needed two coordinates
Well,
both times?
because you have to have some sort of, there's two axes.
What do you think?
We're in two-dimensional space, so
Yeah, it's two dimensions.
two identifiers.
Yeah. But there is a relationship between r and theta and x and y. It's possible. Could you guess how r is related to x and y?
Well, r is kind of like, it's going to be, if you form the right triangle, it's going to be x squared plus y squared.
Almost.
X squared of x squared plus
That's
y
right.
squared.
Square root of x squared plus y squared. That's right. And that comes from forming this right triangle here.
Yeah.
Just erase theta here. This is y and this is x, and then this angle theta is in there. Can you tell me what x equals in terms of r and theta?
So we know x would be r times sine, or r times cosine of theta.
R times cosine of theta. And then y would be?
R times sine of theta.
And those are important formulas that we'll be talking about when we discuss this more completely. But it's neat. So we have an equation x and y, and we have some equations like lines that use those x and y's, and we have other equations that are more naturally described in terms of r's and thetas. One very interesting equation. Do you remember the movie about NASA and the woman who described, Katherine Johnson, who described some satellite equations?
Yeah.
What's the name of that movie?
Hidden Figures?
Hidden Figures, that's right, Hidden Figures. When you launch a satellite up into orbit, it also moves in an ellipse around the Earth. And that equation is given by r equals some number called p, which is some axes in an ellipse, and this is p, this height here,
Alright.
over 1 plus epsilon cosine theta. And epsilon, it relates as a number that when it's 0, you have a circle, and when it's 1, as it gets closer to 1, you get more and more of a squished ellipse. But we're going to see that in a minute. So in that movie, they were studying equations in polar coordinates. And here you would have a distance from, say, the Earth, r. And as the satellite moves around, it's described by, the path is described by this equation, p over 1
Yeah.
plus epsilon cosine theta. So we're going to see that. And then we're also going to see that it's even a little bit more complex than that, than just this simple description. But it's amazing that an ellipse can be written down in such a simple way.
Yeah.
Okay? So why don't we go talk about, or why don't we go back to our Desmos program from yesterday and take a look at this ellipse. All right?
All right.
Alright.